How's it going, everybody? This is Mr. Dickin, and in this video we are going to be solving radical equations. Now, we've already solved radical equations before. However, we've only done radicals written as square roots, right? So we've solved things where the x is trapped underneath a radical, and I'm just making this up. Let's say x plus 3 equals, I don't know, 4. We've solved equations like that before, right? Where we need to access this variable, it's trapped underneath the radical. Well, easy peasy, to get rid of a square root, let's just square both sides. Because after all, a squared and a square root kind of knock each other out. So this becomes x plus 3 equals, well, 4 squared is just 16. And we could solve that to get x equals 13. So we've seen these before. What's going to be different this time around is the fact that we might not be dealing with a square root. We might be dealing with a third root or a fourth root or a fifth root. All right, and that's slightly, but not much, slightly going to change the strategy here. So let's get some definitions done. A radical equation is an equation that has a variable in a radicand or variable with a rational exponent, meaning it's got a letter trapped underneath a radical sign. Okay? The number underneath the radical sign, in this case a, that's called your radicand. And then the index is what type of a radical or what type of a root you're taking. So we're used to square roots, so that has an index of 2. We might see third roots, fourth roots, fifth roots, whatever. Now here are the steps. First, you want to make sure you've isolated the radical to one side. So you want to have a radical all alone. And then you're going to raise both sides to the nth power. What the heck is the nth power, right? The nth power, that's going to be whatever your index was. That's going to be the nth power. So to get rid of a third root, I need to raise to the third power. To get rid of a fourth root, I'll raise to the fourth power. That's what that means. Then it's going to ask us to solve the resulting equation. So we'll solve an equation without any radicals. And we want to check the proposed solutions in the original equation because we might have things called extraneous solutions that come about. And what that means is you get a resulting answer that works for the kind of squared or cubed or fourthed equation, but it wouldn't work with the original radicals, okay? So let's see some examples here. This one I'm going to try a little different, or I'm going to kind of pack a whole bunch on one screen, and then this way we can kind of zoom around as needed as we go. We'll see how it works. Hopefully it works well. Who knows? Who's to say? All right, so let's do number 1 here. We have x plus 3 under square root plus 3 equals x. My goal is to get this radical all by itself. Well, in order to do that, I need to kick the 3 to the other side. So the 3's got to go. So I've got the square root of x plus 3 equals x minus 3. Now to get rid of a square root, I need to square each side. So I'll raise this side to the second power, and I'll have to raise this side to the second power as well. Over on the left, I have just x plus 3, the square root and the square knock each other out. Over on the right-hand side, if I were to kind of think of this as x minus 3 times another x minus 3 and FOIL that thing out, distribute that out, we would get x squared minus 6x plus 9. Well, now as soon as I'm trapped with an x squared, my goal is to get everything over to one side, so that way maybe I can factor or use quadratic formula. So I'm going to set everything equal to 0. So I'll put a 0 over here. That means the x is going to have to get subtracted over, and the 3 will get subtracted over as well. So I'll have 0 equals x squared minus 7x plus 6. And I need to figure out some factors that would work for this. Well, numbers that multiply to be 6 add up to 7. I'm getting x minus 1 and x minus 6. Therefore, x equals 1 and x equals 6. So I have two solutions, but before I get too confident and celebratory, I do want to make sure that nothing is extraneous here. So x equals negative 1 and x equals, positive 1, sorry, and x equals positive 6. All right, so let's plug these in. I'll plug in the 1 first. The square root of 1 plus 3, is that equal to 1? Well, 1 plus 3 is 4. Square root of 4 is 2. 2 plus 3, ooh, that is not 1. So that looks like it's going to be an extraneous solution. Let's try plugging in the 3. See if that works. Or not the 3, my apologies, the 6. If I plug that in, square root of 6 plus 3, well, that's 9, plus 3. So the square root of 9 is 3, plus 3. Is that, in fact, equal to 6? Yes. Yes, it is. So 1 turned out to be extraneous, but 6 actually worked. How fun. Let's try another one. The quantity 2x minus 1 to the 1/2 power plus 2 equals x. Well, this whole piece right here, that's really just saying the square root of 2x plus 1. And that's what I want to get all by itself. So on my next line of work, I'm actually going to rewrite that using a radical instead. And then I'll move the 2 to the other side. So we're going to do the same thing we just did. We're going to square each side. On the left, the square and the radical knock each other out, so 2x minus 1. Over on the right side, I get x squared minus 4x plus 4. Again, I'm distributing / foiling that thing out. Let me change this so the 4 doesn't look like a 9. There we go. Now we'll move everything over to one side. And I get x squared minus 6x plus 5. Well, just like we just saw, factoring that out, I get x minus 5 and x minus 1 equals 0. Therefore, x equals 5 and x equals 1. So I'm going to have those ready to go, but I have to be careful because one of them might be extraneous. I don't know. Let's plug in 5 first. So the square root of 2 times 5 minus 1 plus 2, does that equal 5? Let's see. 2 times 5 is 10. Minus 1 is 9. Square root of 9 is 3 plus 2. 5 checks out, so 5's good. Let's check the 1. Square root of 2 times 1 minus 1 plus 2, is that equal 1? Let's see. 2 times 1 is 2, minus 1 is 1. Square root of 1 is 1. 1 plus 2 is not, so that does not work. We're not getting much love for the 1s today. So that is an extraneous solution. All right. Number 3 is going to be awfully similar to the ones that we just did. So just in the interest of time, we'll kind of bypass this. I do want to look at number 4, though. So let's take a look at number 4. 4 might look intimidating because we have 2 radicals. So like, which one do we isolate, right? Well, here's the thing. As long as you got one of them isolated, you're good to go. And by isolating the left side, we've also kind of got the radical isolated on the left. When I say isolated, I mean there's no plus or minus or any coefficient out front or anything like that to kind of mess things up. So number 4, I can just jump straight into squaring each side, and that's going to get rid of the radicals for me. So 3x plus 12 equals x plus 8. I've taken what kind of looked like an intimidating problem and really turned this into an Algebra 1 problem. So let's move all the x's to one side. We'll move the constants to the other. So we've got 2x equals negative 4, therefore x is negative 2. So I'll square that up or circle it now, but I do have to check because it might be extraneous. Let's double check. Let's see. If I plugged in negative 2 for x, I have 3 times negative 2 plus 12. Is that equal to the square root of negative 2 plus 8? Let's see. 3 times negative 2 is 6, negative 6, plus 12 is 6. Over here on the right, yeah, that works. All right, rad 6 is equal to rad 6. All right, let's see some spicier problems here. Again, all these that we don't get to, you guys do have access to all of these on the completed notes document that is available to you. So you do have access to all of these. But with so many similarities, we just, in the interest of time, we won't explain every single one. Let's go ahead. Let's say we'll do number 6. 8 and 9. We'll do 6, 8, and 9. And that should get us pretty well prepared. All right. So for number 6, I want to get my radical isolated. So this is going to end up being the radical term. So that means the 4 is going to have to go to the other side, and we have to divide out the 2. So I'm going to write this real quick with the 4 moved over. But instead of writing this with a rational exponent, I'm actually going to write it as a cubed root. So 2 times the cubed root of 6x minus 3. Please do not fall into the pitfall of trying to distribute into these parentheses. If a parenthesis chunk ever has an exponent attached, you cannot distribute anything in there. So please don't make that whoopsie daisy. All right, we'll divide out the 2. So if I divide 2 from each side, I'll go to the right now. The 4 becomes a 2. So I have the cubed root of 6x minus 3 equals 2. So now here's where I get to raise each side to a certain power. And to get rid of a third root, that power is going to be 3. Normally to get rid of a square root, right, we squared each side. Well, to get rid of a third root, you raise each side to the third power. So on the left, I just have 6x minus 3. On the right, I have 2 to the third power, which is 8. 2 to the third power, which is 8. And now we can solve. Let's add the 3 over. So I'll get 6x equals 11. Therefore, x equals 11 sixths. Now, some of you might be looking at that and be like, how the heck are we going to double check that for extraneous solutions, Mr. D? What are you trying to pull? What is this nonsense? You want me to plug a nasty fraction into this to check? Well, it's really not going to be that bad, because if you did it correctly, things might cancel out. So let's see. If I did 2 times the cubed root of 6 times 11 sixths minus 3 minus 4 on the outside, and I want to know if that's equal to 0. Well, 6 times 11 sixths, those 6's cancel out. So this is really the cubed root of 11 minus 3. So now this thing simplifies to 2 times the cubed root of 8 minus 4. Is that equal to 0? Well, the cubed root of 8 is 2. 2 times 2 is 4. 4 minus 4, yep. 0, that checks out. So don't freak out if you see some fractions. Fractions are numbers too. All right, number 8 is going to be very similar. And then we'll wrap it up here with number 9. We'll wrap it up with number 9. Number 8, I've got my radical right here. It's written with a rational expression, but it's really a radical. Anytime you have a fraction exponent, you have a radical. Okay, so I'm going to move the 9 over. So we'll have 3 times the cubed root of 5x minus 1 equals 9. Then we'll divide out the 3. So now I have the cubed root of 5x minus 1 equals 9 divided by 3 is 3. Then we'll raise both sides to the third power. Third root, third power knocks each other out. So I have 5x minus 1 equals 27. Well, let's move the 1 over and divide out the 5. If I move the 1 over, I get 28. Divide out the 5, 28 fifths. If we were to plug that back in, 5 times 28 fifths, 5's cancel out. This is just 28. 28 minus 1 is 27. The third root of 27 is 3. 3 times 3 is 9 minus 9. Shazammers, 0. 0. All right, last one here. I think it's the last. Actually, I'm going to check. Actually, you know what? Number 6 might be more interesting. Let's see. Let me see which one looks more interesting. Tied for interestingness. We'll go with number 9, as promised. All right, so we have 2x minus 1 to the 1/4 power. Minus 2 equals 1. Again, there's my radical term. I want to isolate that. So I've got the 4th root of 2x minus 1. Again, I prefer to write these with radicals instead of rational exponents. And then if we kick the 2 to the other side, that'd be a 3. We now raise both sides to the 4th power. If you want to get rid of a 4th root, it goes to the 4th power. So I have 2x minus 1 equals 3 to the 4th. That's 3 times 3 times 3 times 3. Now, some of you might be attempting to do this mentally, which, good. And you'll get 3 times 3 is 9, times 3 is 27. 27 times 3, what is going on with that? Let me give you a little hint here, fellas and ladies. 3 times 3 is 9. 3 times 3 is 9. Do we know 9 times 9? Heck yeah, that's 81. All right, so we have 2x minus 1 equals 81. Let's move the 1 over. 2x equals 82. Divide out 2, we get x equals 41. Double check for accuracy, plug that in. 2 times 41 is 82. Take away 1, I get 81. 4th root of 81 is 3. 3 minus 2 is 1. Yes, we've done it correctly. All right, folks, that is it for this video. Hopefully, we learned something new. You know the drill. If you have any questions, please do not hesitate to ask. And as always, good luck, have fun, be safe, roll tide.